Okay, so in this video, we are briefly going to talk about trapezoids. And trapezoids are not really that special among other quadrilaterals. They only have one distinguishing characteristic, and that is they have one pair. So they're quadrilaterals with one pair of, I guess I should write that down. Of course, we see in the picture they're quadrilaterals, but just in case, quadrilaterals with one pair of opposite parallel sides. Okay, so right here, AB is opposite of DC, they're parallel. And then, of course, we see, the other two opposite sides, the other pair, right, they are not parallel. Okay, and same goes for this other guy here, one pair of opposite parallel sides. The other pair of opposite sides are not going to be parallel. Okay, so let's talk about diagonals, right? And again, there's not anything special about the diagonals on trapezoids unless we're talking about an isosceles trapezoid. Okay, so here we have it written, diagonals are only congruent on isosceles trapezoids. Well, what is an isosceles trapezoid? This trapezoid right here is isosceles for an obvious reason. That's because the length of AD is congruent to the length of BC. Just like an isosceles triangle, right? We have two congruent opposite sides. Okay, that's what makes it isosceles. Okay, now what is interesting here we see is that we also have base angles are congruent. Okay, so if I call this, theta 1, I don't know why I numbered these differently over here. I call that theta 1 and theta 2. I see that theta 1 is equal to theta 2. And analogously, we see that alpha 1 is congruent to alpha 2. Okay, so the only interesting stuff that happens on isosceles trapezoids like this one here, right? So let's talk about the diagonals real quick. So the diagonals, if I go ahead and connect from here to here, cool. I like that it just didn't do what I wanted it to do. It just randomly put my little line segment over here. Thank you, Microsoft. But if I go ahead and connect my diagonals, so diagonal AC, and let's see if it'll allow me to duplicate this. And I connect B to D, right? I can plainly see that something else is true. I can see that diagonal AC is congruent to diagonal BD. Okay, they're precisely congruent. They don't bisect or anything like they do on parallelograms, but they are the same length. So the distance from here to here is the same distance from here to here. Okay, that's only true on isosceles trapezoids. Okay, if I do this same deal over here, if only my right clicker would work, I guess it's not. If I do the same thing over here, right, if I connect, vertex F to vertex H here to form a diagonal, and I do it again and connect vertex E to vertex G, form another diagonal. I mean, clearly we see that we do not have, EG is not going to be congruent to HF. Okay, so that kind of thing only happens, the special stuff only happens on isosceles triangles, or isosceles trapezoids. What's the matter with me? Okay, we also see we don't have any congruent angles on these guys. Okay, so if it's not isosceles, all of these angles are different. Theta 4 is not the same as theta 5, not the same as theta 3, nor theta 2. Okay, so nothing really special happens with normal trapezoids as opposed to isosceles. Okay, so that does it for this video. If you have any questions over trapezoids, come and see me. Goodbye.